Welcome back to TinkerCAD Arduino programming. So we click this starters Arduino. Okay, so breadboard, blink, fade, button. Okay, so we are now on analog. Okay, so analog input, but we're going to choose this analog read serial. Okay, so in the analog read serial, we have this potentiometer. Okay, so potentiometer is a variable resistor with a three terminal. Okay, so let's try to change this to, let's say, 10K. So we duplicate the potentiometer, then we're going to get a multiplier. Okay, so how does a potentiometer works? So if you're going to connect it on the side by side, and you're going to take the resistance. Okay, let's try to play. Okay, so you notice that it's 10K. I'm going to turn the knob so it remains constant. Okay, so the side terminal 1 and the last terminal, no, the side by side terminal is constant 10K. However, if you're going to at the center, okay, so let's try to play. Okay, so its maximum is 10K. Then I'm going to rotate the knob, set the center, so it's 5K until it becomes 0 ohms or short circuit. Okay, as well as if you're going to connect it on the other side, okay, it's the same thing, except that the result would be opposite. This is now the maximum side. Okay, and going the other way around will be the minimum side. Okay, so that's for the uh, centimeter. So technically, uh, the two sides, these two terminals, okay, one is the ground and the center must be on the one of the analog input terminals, so say AO. What will happen if we're going to supply 5 volts? Okay, so let's try this first here. So let us say this is red. Okay, then this one is connected to here. It's black. Okay, at the same time, okay, so black. Then this time, going to measure the green. Okay, so of course, this is also the ground, the black side. Okay, so this is black. Okay, so this will become voltage. Okay, so it's now translated to voltage. Okay, so from 0 voltage to maximum of 5 volts, considering that it's connected to the 5 volts. Okay, so that is how you're going to supply potentiometer. Okay, so we're going to remove this one, but instead we're going to monitor this potentiometer. Sorry, this must be black, and this must be at the center. Okay, so it's green. Okay, so let's do it again. Play. So 0 volts, maximum of 5 volts. Okay, now let's look at the code. Okay, so convert it to text. Continue. Let's zoom. Okay, so this time you notice that in the void setup there is a function serial. Okay, so this is the serial communication. And by the way, the AO terminal is the mode of AO is input. Okay, so the pin mode of AO is input. And the serial communication is 9600. Uh, this is the baud rate, bits per second, I guess. So serial that begins. So you start communicating. Uh, the Arduino will communicate with the laptop or the computer that is connected to. Okay. Then, of course, we assign a variable. That's a global variable sensor value, the value of the potentiometer. Okay. So its resistance is being converted into uh, analog. Okay, so analog read. So instead of digital read, the last time previous, it will be then analog read, and it will be the AO. Then it will be printed. No, it will be printed in the serial communication. The value of the analog read. Of course, do not forget to display delay. So serial that print line is will be printing it in the serial monitor here with a new line. Okay, so let's try to start simulating. Then let's click this serial monitor. Okay, so you notice that the analog, the 10-bit analog value is 0. Why is that? Because the potentiometer is at the minimum point. Okay, so as we increase this knob, becomes 102. Then what will happen if it at the center is 511, and what the maximum is 1023. Okay, so it's a 10 bit, so 2 to the 10 is 10 bit analog. Okay, so 2 to the 10 is 1024. So therefore the range for this one is 0 up to 1023. So okay, so if it is at the middle, okay, it will be 511. Then of course if it's the minimum, it's 0. Okay, so what will happen if we're going to uh, connect it to a PWM LED? Okay, so let's stop. Okay, so we're gonna add a LED. Okay, so we're going to connect a LED, particularly an PWM IO or output terminal. Okay, so we type in LED. Sorry. So we go to basic. Okay, so I have here a LED. Anyway, we're gonna connect it here. No, it should be a PWM. Okay. Uh, Perhaps in the anode. Okay, so the anode must be connected in 9. Okay. Then a resistor is in series. This one connected to the ground. So it should be black. Okay, so we're going to edit the program. Okay, so we're gonna add 9 pin mode, 9, 9 at the input, rather output. Okay, then we're gonna assign the value, no, using analog, right? Okay, so we're gonna turn on the LED with the value of the sensor value, or okay, so let's try to start simulation, but this time, oh, sorry, analog, right? This should be 9. Okay, comma sensor value. Okay, so start simulating again. Okay, so it's lighting low because the value of the potentiometer is low. Okay, so start the simulation again. What will happen if I'm going to turn on? Okay, so you notice that the LED, as I'm going to, okay, so the LED now is brightening on maximum. Okay, however, if I'm going to make it minimal, so you notice that it's turned off. Okay, so another way of doing it is connecting it to the turbo motor. Okay, the electric turbo motor. Actually, there's an example here where there is a servo motor. Okay, but anyway, we're gonna type in turbo motor. Servo. Okay, so we choose this blue. Okay, so take note, a servo motor is also a geared motor, except that it has an internal circuit inside, especially a potentiometer, to determine the position. There are two types of servo motor, positional and continuous. Okay, so the positional is the most common. It has 0 to 180 degrees position, whereas the continuous is 360 degrees. Okay, so take note this orange is connected to the signal, no? Signal wire. Okay, so this one must be 9. Okay, so let's make it orange, whereas the red is connected to the power supply. So usually it's powered using 5 volts. It's powered using 5 volts. So we're gonna connect it here. 5 volts. Then the brown is connected to ground. Okay. So take note that the servo motor is controlled using a PWM. So since it's already connected to analog, analog right here. So let's try if it will move. Okay, let's start simulation. Okay, so it will move. Okay, okay. So that's the principle of a servo motor. Okay, it will move based on the uh, pulses. No? However, it's not rotating on its 0 to 180 degrees movement. Okay, so you need to revise the code. Okay. So we're going to add, okay, so servo. Okay, we're going to create an object servo. So servo 9. Okay, and this time going to add servo 9 that uh, connect. Uh, we open an example of a servo motor. Okay, so let's try to look at the code. Okay, so there is a servo attached. You need to attach the servo. Okay, so perhaps declaring the library servo.h. Okay, so we're going to do that. Then we're going to initialize position the servo. Then we have here a servo attach. Okay, so we're going to do that. So we go now to here. So So we're going to declare a variable as well. Position. Okay, so let's say it's equal to 0 degrees. Then followed by servo dot attach. Okay, so by default, you can only declare what pin, the PWM pin assigned. Okay, then in here, we're going to use the instead of analog, right? We're gonna write here servo dot forgot. It's servo dot right. Okay, so servo dot right. So servo dot servo dot right. And it will tell you what uh, angle. So we might as well use the sensor value. So the sensor value will reach more than 180 degrees. Okay, so you can also divide it by, let us say, divided by 1000. Yeah, divided by 5. Now we can do that. Okay. Anyway, position is not significant in this code. So let's try to play. Okay, so let's check. Start simulation. Okay, so in the code, we missed the Servo 9. This is Servo 9, not Servo. Okay, so continue. Okay, so we need to include a library. Include, okay, the Servo dot 8. Okay, so try to start simulation. Okay, so let's try to move the potentiometer. Okay, so there you go. Okay, you can now rotate the servo motor. Okay, using the potentiometer. Though the value is from 0 to around 200 plus, and the maximum is 180. But anyway, okay. So let us say, okay, the 0 degrees. Okay. Then how about the center, around the center? Okay, it's around that is supposedly the 90 degrees. Then 180 degrees is around here. Okay. Okay, so that's it for the analog. No, you forgot the serial monitor. Okay. Okay, you notice here that that's the value. Okay, so that's it for the servo motor analog input using the potentiometer or analog read, as well as the serial print. Okay.